Hello everyone, this is the Calorimetry Lab Introduction. So, for this lab, the purpose is we want to experimentally calculate the specific heat of three different metals. How we're going to do this is we're going to heat these metals up, drop them in some water, room temperature water, and see how much the temperature changes. Okay, so we need a couple materials for this lab. We need the calorimetry cup with the lid. This is styrofoam, and just like the Archimedes principle lab, we need these three metals again. We need the lead ball, the aluminum cylinder, and the copper cylinder. We also need two more things. We need a chopstick, and we also need the water heater right here. So step one is we want to record the mass of these three metals. And we also need to record the mass of the empty calorimetry cup with no lid on it. Okay. Now, step two is we want to turn the heater on max and submerge the lead ball for 20 minutes. We can do this because the lead ball has a little string, which we can put through the lid, the styrofoam lid, and put the chopstick through that so that the lead ball will just hang off the chopstick in the water. And the metal, don't let it touch the bottom or the sides because then it won't be quite accurate. Once we have it submerged in here and on max, we want to leave it for 20 minutes so that the metal can reach the boiling temperature of the water. So while we're waiting for that, we need to take this calorimetry cup, fill it up most of the way with tap water, and now we need to record the mass of this and the temperature of it. So this is the initial temperature and mass for the water. Okay. Now, step four, once the metal has been fully submerged for 20 minutes, we need to record the boiling temperature of the water. We need to write that down on our lab sheet. Then the next part is we need to take this chopstick lid and lead ball and put it on top of the styrofoam calorimetry cup. Make sure the lid sits on properly and that the lead ball does not touch the bottom or the sides of the calorimetry cup. And doing this, we want to gently swirl the cup just to stir the water around and help mix it evenly. While you're doing this, you want to have the temperature probe from the multimeter hooked up inside. So there's going to be a little hole that you can stick the probe through, and you want to record the highest temperature. And you try not to let the probe touch the styrofoam or the metal for more accurate results, because then you might get a higher or lower reading than what's expected. So step five is we want to repeat this procedure for the aluminum and copper cylinders. But for these cylinders, we're only going to need 5 minutes in the boiling water. Okay, so now the final part is going to be on the back of the lab, is that we want to calculate the experimental specific heat. So we know the mass of the metal and the initial temperature of the metal, and we know the initial mass of the water because we measured the empty calorimetry cup and the full calorimetry cup, and we also know the temperature of that as well. So using this, we are able to calculate the experimental specific heat for each metal, and then we can go ahead and find out how much we were off by using percent error by looking at the actual values for each different metal. So yeah, if you have any questions, feel free to let me or Professor Bond know. But other than that, good luck with the lab.